Okay, folks, we got another twofer. We have Math Model Semester 2, Unit 2.21, and Geometry Semester 1, Unit 2.71, and it's the study of similarity theorems and proportional reasoning. Okay, so this is the fun part. We get to review a little bit. So it says activating prior knowledge by practice number 1. Similar triangles have the same shape, but not necessarily the same size. Corresponding angles are always congruent, and corresponding sides are proportional. Okay, so making mental images and summarizing in practice 2. How can you use dilating and congruence transformations to prove two triangles are similar? Well, the first thing we can do, number 1, we're going to dilate one triangle. We can do this. We can dilate one triangle to match the size of the second. We can translate, rotate, or reflect the triangles until they overlap. That's number 2. Translate, rotate, or reflect the triangles until they overlap. Number 3, if the overlapping triangles match exactly, they are congruent. Number 4, that means the original two triangles are similar. Okay, let's move on. We have 3 similarity postulates that we are going to focus on in this lesson. And our first one is going to be angle. Okay, practice 3, summarizing. If angle similarity postulate. If two angles of a triangle congruent to two angles of another triangle, then the triangles are similar. Let's write that down. Okay, so in practice number 4, it says use visual cues. What is the length of PQ in the triangle shown below? Well, we know that angle M is 112, which is here. And angle P is 112. And likewise, we know that angle O is 30 and angle R is 30. So just by knowing, let me undo that. Just by knowing this angle and this angle is congruent to this angle and that angle, then we know that the triangles are similar, so the sides should be proportional. So we got a step-by-step on how to do it. Let's look at it. Step 1 says prove the two triangles are similar. Well, we just did that because we know that they are angle similarity. And I got a bonus question. That is my bonus question. What's the measure of angle N and the measure of angle Q? There's your answer. It's irrelevant, but I was hoping you knew that all the angles in a triangle got to equal 180. And so with 112 and 30 gone, all you got left is 38 degrees. That's off subject, but hey, it's always good to review. Okay, so if the measure of angle M corresponds to angle P, then the measure of angle M is equal to the measure of angle P, which also means that angle M and angle P are congruent. And I'm just reading right here. And then if the measure of angle O, now I'm over here on this side, it corresponds to angle R, then the measure of angle O is equal to the measure of angle R, and angle O is congruent to angle R. That's a lot to say, but that's okay. We can say that those two triangles, M and O, is similar. Now I'm reading right here. M and O is similar to triangle PQR by the angle postulate. So you would just put an AA there. All right. So we're going to set up a proportion. That's step 2. Set up a proportion with the side PQ. So PQ corresponds to MN actually when you look at your triangle. And QR corresponds to NO. So we're going to replace the sides with numbers and variables. Now, on that last triangle, they had side lengths labeled. So if yours don't match up or you need help, let me know. But MN corresponds to 27. And with a proportion, all you do is cross multiply and then divide. So we multiply x times 50, and that's how they got 50x. And then we multiply 40 times 27, and you get 1080. And the last step is to divide. So you get 21.6. That means if you go back to the other side and you're looking for MN, no, not MN, and you're looking for PQ, Yeah, it said find PQ. P PQ equals 21.6. So where you see an X at, you can go back and put that on your practice problem number 4. Okay, side similarity. So if the lengths of all corresponding sides of two triangles are proportional, then the triangles are similar. Let's write that down. Okay, so proportional is the word that goes right there. I thought I paused it, but that's okay. Let's go ahead and do a practice one. So it says, are triangles, ABC and triangle DEF shown below similar? So we have, oh, this is a good one because the picture shows with the thingy. So identify pairs of corresponding sides. So AB and DE correspond, and then BC corresponds to EF. Try to go in order if you can. EF. And then CA, that segment, that's that little line on top. CA corresponds to FD. And we put a line on top for segment. So AB, which is here, and DE, which is here. I'm just going to write those as a fraction, just as it's given. So that one is 20 over 10. And then BC is 14. And EF is 7. So 14 over 7. And CA is 12. And FD, 6. So 12 over 6. And I'm going to go back and put it in blue because I didn't think the green would show. And then it says, simplify all the ratio fractions. That's number 3. Well, 20 over 10, 14 over 7, 12 over 6 are 20 divided by 10, 2. 14 divided by 7, 2. 12 divided by 6, 2. So it says compare the fractions. If they are equal, they are proportional. So look at this. 2, 2, 2. Yes, it's proportional. That means the triangles are similar. So to answer this question up at the top, always make sure you answer your question. It's a yes. And if you want to know why, it's because it's proportional. Right down here at the bottom, it gives you the whole... I can't think of the word. Ha! I got it. Almost conditional, because conditional statements has if then. So if they are equal, then they are proportional. Ha! That's another lesson. I forgot this was over here. So in summary, up at the top right here, what you see, all the corresponding sides have the ratio, which is 2. And because they have the ratio 2, triangle ABC and triangle DEF are similar. All right. So here's our next theorem right here. Side angle side similarity. And what I want you to make note of is that the word angle is between the two sides. So know that the angle, the corresponding angle, must be between two sides. Okay? All right. So let's read it. It says, if one angle of a triangle is congruent to an angle of another triangle, and the lengths of the sides, including these angles, are proportional, then the two triangles are similar. Give me a second to write this down. Okay, so I went ahead and wrote it down. It says, what's the length, on practice number 8, says, what's the length of PR, that segment, in a triangle shown below? Now, I just want to point out that PR happens to be this segment right down here at the bottom, which corresponds to MO. Okay, so it says, prove the two triangles are similar. MN corresponds to PQ. Let's write that down. And let's put our bar above it because it's a segment. NO corresponds to QR. I'm going to write it over here because I write too big. Oops. So that goes right there. So MN over PQ has ratio 27 over 18, which actually reduces to 3/2. And NO and QR has a ratio of 18 over 2, which reduces to 3/2. Okay, so I just want to show you, and hopefully it's not blurry, what I did to get the 3/2. If you can't do it by hand, that's okay. So you start at the home screen, which is just blanking, and you want to press alpha and y equal. That's going to get you to the fraction function, the numerator over denominator. So you can put 27, arrow down to get 18, and you see our answer 3/2 pops up. And you can do the same thing with 18 over 12. So 18 divided by 12. And hit enter, and it'll give you 3/2. Now, if you can't remember that, or if alpha y equal doesn't seem to make sense and you want to do it the old way, you can always do 27 divided by 18, and you get 1.5. But if you want to turn to a fraction, you press math, which is right under alpha, and you press 1 or enter, and it'll turn it into a fraction. So you get the same 3/2. Okay, if you need help with this, you let me know. Okay. Okay, so we're gonna keep going. It says angle N corresponds to angle Q. You see this angle right here, 81 degrees, corresponds to that one, angle Q. And if they're both 81 degrees, then angle N is congruent to angle Q. All right. And we can say, because the two sides were proportional and they have an angle that's in between those, by side, angle, side, postulate, those two triangles are similar. So now we can figure out what PR is using a proportion. So PR over MO, highlighted in that brown color, I was hoping for orange, is those correspond, but MN, which is over here, I'm gonna do green. MN in green corresponds to PQ. So PQ right up there. And then we plugged in the values. So PQ is 18. And once again, since you have a proportion, you cross multiply and divide. So x times 27 is 27x, and 30 times 18 is 540. And then you divide both sides by 27, and you get x is 20. So PR, is 20 units. Okay, so this part right here, practice 9, it says drawing inferences. You're going to complete the inference and diagram, write congruence or similarity in each blank. So it's a fact that if a triangle is congruent, then it is also similar. Now that right there, here's a hint for you, is probably going to show up on a quiz. Let's keep going. And so what is it that we can infer? All congruent postulates and theorems prove similarity. That's what we write. Hold on. Okay, so in this line, we put congruence, all congruence postulates and theorems, they can prove similarity. So shortcuts to prove similarity, and that word actually goes here by angle. There are shortcuts that we can prove congruence. And I'm going to just put the congruence symbol, which is an equal sign with a little tilde above it. So just as a reminder, the congruence symbol looks like that, and a similarity symbol looks like that. So that's our that's the end of our lesson. And if you have any questions, of course, I am here for you. Ms. Gable loves you very much. I'm going to encourage you to do the checkup practice problems. And if you need help, of course, just ask. Okay? You have a nice day. Bye-bye.